Okay, I'm going to go ahead and get started. My name is Wes McDermott. I am the community manager with Algorithmic, and this is our second stream on Twitch. And this week we're going to be talking about physically based rendering, or PBR, in Substance. Now, physically based rendering is it's quickly becoming a pretty good, I guess I would say, mainstream in the term of kind of next gen workflows. And it's something that we've supported in Substance since version 4. And so what we're going to do in this stream is we're just going to go through and just kind of talk about, what is PBR, how does it work in Substance? And then I'm also going to go over just a few guidelines, some texturing guidelines and things like that. So what we're going to do is just kind of run through just a few, I got a few talking points here, and then I'm also going to show you how this works, not only in Substance Designer, but Substance Painter as well. And so what I'm going to kind of showcase a little bit is this little crossbow that I kind of worked on. So I had just this model and went through and just kind of textured it with the guidelines and kind of the principles that we're going to talk about in this stream. And so first thing we're going to do is we're going to say, well, what is it? What is all this PBR stuff? We hear about it a lot, Substance, we talk about it. It's now something that's inside the Unreal Engine 4. Unity has made an announcement where they're going to support this new pipeline in Unity 5. And so when you come to think about what it is, it's really just a method of shading that provides a more accurate representation of how light interacts with surfaces. So it just helps us to create real-world surfaces. It helps us to be more consistent, and it helps us to do this a bit easier. And so what are the benefits to this? Why I guess you could say, why do we care? And the benefits would be that it's easier to create realistic assets. Basically, you just plug the textures in, and whatever you do, it should look right. And then it removes the guesswork. As PBR, it's based off scientifically accurate formulas. So, like I said, it removes a lot of that guesswork that we as 3D artists would go through before, where, we were trying to determine, the cheat of using a specular map and trying to, have a computer control reflectivity and specularity as two separate controls and all that stuff. Because the reason we did that is because the hardware and the I guess the shading and the technology just wasn't there at a level where we could represent surfaces as realistic as we can now. And so another really big point to this is that the assets will look good and, most importantly, accurate in all lighting conditions. So, we're all 3D artists. You probably, I know that I did this a lot, but that you'd work on your maps and, you'd have them in your renderer and you'd tweak the lighting. It'd look great. But as soon as you change that lighting dramatically, like go from night to day, or you change something, you'd notice that, well, that metal that just looked so awesome in scene 1 does not look too good in scene 2. And then so you go through this really complicated setup of changing your lights and doing all this stuff. Well, PBR gets rid of that. So the idea is that your artwork is going to be very consistent in all lighting situations, which is great. So basically you just throw new maps in, you have your maps, you throw in new environments, new lights. You don't change a thing in your maps. It's all kind of set. And then ultimately here we've got, it provides a workflow for creating consistent artwork, which again is really something if you're working in a pipeline or if you're working with other artists. If all the artists are adhering to a certain set of guidelines and preparing textures a certain way, it makes it really easy to share assets and stuff. And then finally, something to think about is, well, this is all well and good, but how does it affect me as an artist? And what it does is that it makes us, we need to think differently about how the maps are created. So a lot of and as you'll see as we go through this presentation, a lot of the heavy lifting is done by the shaders and stuff. But we need to think differently about how we create the artwork. And that can be a barrier, or it can be something that's, easy. It just depends. I remember when I was first learning this workflow, it was kind of difficult for me because I was so used to, making specular maps and having these things, having the reflectivity and the specular being, two separate things and all this kind of stuff. And it was, difficult to think about this new map mindset. So yeah, there's new maps for us to think about, new map types, and some rules and guidelines that we'll need to follow. All right, so with this said, let's just kind of dive a little bit deeper into, some key factors about what, PBR is. Okay, so there's some key factors here. And the first thing I want to mention here is energy conservation. So basically I have this note that says, a light ray leaving a surface is never brighter than the value it had when it first hit the surface. So basically that means that rougher surfaces are going to have larger or they're going to appear to be dimmer highlights. the same amount of light is reflected, but just a rougher surface is going to spread these light rays across. And so let me just illustrate what I'm actually talking about there. So here we are in Substance Designer, and I will point out that I'm actually using 4.2.1, which is actually going to go live, I think, tomorrow. So there's some new changes in here. We also have another new filter for switching between PBR modes, which is really nice. I'll show you that. But anyways, just a little side note there, 4.2.1 is going to hit the streets tomorrow. So here we are. We've got this little this sphere here in an environment. This is basically set up to be like a chrome. I'm using PBR right now. We're going to go into how I set this up and how all this works in Substance Designer. But for right now, let's just talk about what I was just saying there about energy conservation. And so what I'm going to do, just to demonstrate this, we'll look at our sphere and we can see that, well, we're in this environment and we have some highlights are reflecting. So you can see that, we see some highlights here and here. I'm going to come over here to my roughness map. Again, don't worry about, what I'm calling this or what I'm doing here. We're going to cover this stuff. So right now, this surface is not perfectly smooth. If it was perfectly smooth, it would look like this. And so we basically get almost like a perfect mirror. So it's very, very smooth. As we start to introduce a little bit of roughness to this, you can see that we start to get these little highlights. The light rays that are like coming in off of our environment are basically hitting our sphere, and the roughness of this surface, or what we're approximating the roughness through this map, is taking those light rays and just kind of spreading them out across the surface, and it's basically making the highlight a little bigger. So as we start to increase roughness, you can see, well, the highlight's getting bigger and bigger because, again, the light rays are spreading where they're spreading. And so here's where we actually start to see this energy conservation come into play. So as I start to make this rougher and rougher, I want you to take a look here at this highlight. So you can see we have this nice concentrated highlight right now. But as we start to just kind of spread this out more and more rough, you can see the highlight is getting larger and larger, and it appears to go dimmer and dimmer. So again, all the light rays are being just scattered and reflected across all over the place. Now, the point about this is, and the key factor when it comes to PBR, is that this is energy conservation, meaning that the light is not getting, it appears to be dimmer, but the rays are not, they're not reflecting a different value, okay? It's just that the rays are being scattered so much that it appears to be dimmer. The same value that we're seeing here, so the same light rays that are reflecting here, are being reflected here. It's just that they're more scattered because we've increased our roughness. So that's what we're talking about there when we're mentioning energy conservation, which is a big key point here in PBR. And the other point of this is Fresnel. So the Fresnel, which is something that, as 3D artists we've used, numerous times, especially in things that we've set up in our rendering, incident angle, stuff like that. But Fresnel takes a really key role in PBR, and the Fresnel is handled by the shaders. And it basically gives us this kind of state where all materials are 100% reflective at grazing angles. So, anything is reflective, or basically all things are reflective. And really what it comes down to is what is reflected at what is retained to, or what is referred to as this F0. So this F0, and this is something that you'll hear a lot during PBR talks and things like that, but F0 is basically your Fresnel 0. So if we look at a Fresnel, right now, if you take a look at this sphere, we're looking at this straight perpendicular, right at it. So this is F0. Now, as we start to move across the angle of this, you can see that we have this kind of this slope angle here. We're coming up offwards of 90 degrees. So what it's saying here is at F0, what is the reflectivity of this? And so all materials are going to have some type of setting or some type of value for reflectivity at this F0. And we'll talk about that more in depth in just a bit. So anyways, I'm just letting you know that, we're talking Fresnel. We have this Fresnel equation that's working here for this PBR, and this is something that's handled by the shader. And that the other point is that all materials are 100% reflective at these glancing or grazing angles here. So here we have an F0 value where, we're not as reflective as we are on the edges. On the edges, we will basically move towards 100% reflectivity. And then finally, another key factor here is roughness is king. So our roughness map is king. The roughness map is where you're going to give your surface all of its character. This is where you, as the artist, have the most control and look and feel of your surface. So roughness is basically everything in PBR. And as you'll see, it actually makes things a bit easier here. And so 3 things that control the intensity of a reflection. Again, we talked about Fresnel angle. Now, one of the things that I want to point out is that this isn't something that we set. This is controlled by the shader. We don't have to set a Fresnel angle. roughness, and we talked about roughness and how it relates to energy conservation here. So again, roughness map, that is the part where we as the artist have full control over. And then finally we have this F0 reflectivity. So again, we're talking about this F0 reflectivity. We can't set this directly. Again, this is something that's controlled by the shader, which we'll talk about in a minute. So here another example is, this time let's go over to Substance Painter. And here I have Substance Painter, similar kind of setup here. We've got this chrome, or this sphere here that it's set to copper. Let's go ahead. I've got a fill layer here inside of Substance Painter, and let's just go over to some of our paint materials themselves, and let's just pick something here like rubber. So I'm going to just hit rubber, and you can see that, well, obviously this looks a lot less reflective than the copper did, and we're talking about rubber here, so we're not talking about a metal anymore. But what I do want to point out is you can see here from the edges that this is still this is still reflective. This is still reflecting light rays, and so you can see that right here in the area of this rubber around F0, there's going to be a very specific value of reflectivity. And as we move to our glancing angles and we come all the way up here, and if we look at it just the right angle, it's going to move all the way up to 100% reflective in that area. So here we are with the material, and just kind of again just demonstrating that Fresnel equation that's working. Again, something I don't have to work with or change or anything. It's just part of the system itself. So now we'll just come back over here to our slides, and this is the point where I actually want to talk about PBR and Substance. And so Substance Designer supports 2 PBR models. So there's 2, and one of the things to think about this is PBR, there's not really like a special standard. There's not like this gold standard. It's kind of like normal maps. It's like, or normal map tangent basis. It's not like, okay, hey, this is the one that we're all going to use, so every application is going to support it this certain way. That means if I'm working with PBR maps and Substance versus, Toolbag or some other type of program, they're all, it's all going to be, perfectly matched. So unfortunately, there's not like a gold standard to that. However, you could still say there's pretty much a standard in the sense that we have these 2 models. So Substance Designer supports the Disney BRDF model, and it also supports a specular glossiness model. So the Disney BRDF is the model that we're really going to talk about. It's the one that I like the best. It's the easiest to use. So what is this? So it uses what's referred to as a metallic and a roughness map. This model here, it's quite a lot easier to author, just in my opinion. It's just easier to work with, and as you'll see, we go through when we actually get into the texture guidelines. Hopefully, you'll agree it's a lot easier to work with. And then the other thing about it is that the reflectance value for metals that's placed in the diffuse or albedo texture. Again, we'll talk about how that works. And then since the way this system works, I actually find it to be it's less prone to error too. So like if you're working with a lot of artists and you guys are all using the same Disney BRDF model, it tends to be like I said, easier to author the maps, and there's a little less leeway there for major errors and stuff like that. And so the other model that we support inside of Substance Designer here is specular glossiness. Now, Substance Designer, I say, supports 2. So Substance Designer, again, supports Disney, and then it supports specular glossiness. Now, Substance Painter, on the other hand, only supports the Disney BRDF model at the current beta time. And so the other model here is, again, we're talking about physically based. We're talking about a lot of the same principles, but we're really driving 2 different maps here, a specular and a glossiness map. And so, real quick, let me do a demo of this. Let me take a look.